Andrew, channels C and D. So let's go, guys.
So, hello everybody. Everyone is listening? Good. So, hello everybody. Good morning. It's the first DConf, as Akira said. I'm really glad to be here. It's a great opportunity. So, thank you for the invitation. Thank you all for being here so we can exchange a few ideas. And the don't panic thing never makes so much sense. Let's talk about data. You know, I'm a closurist, so this is a topic that I spend a lot of energy. It's really a recurrent theme on our community. One thing I want to ask you is how much your data is worth? Your data of your systems, the systems you build? It's a tough question to answer in precise terms, but I would say that probably a lot. We often, when we talk about data, we talk about the value of data. Information is a valuable resource. It's from all the accumulated data on our information systems that most of your product's value propositions come from. Fields like data science and techniques like machine learning take this information and extract knowledge. Taking e-commerce as an example, they smash together all the purchases data and build recommendation systems so they can be more effective at selling things to people. And something more close to us, A/B testing. A/B testing, you get all the access patterns of your users and use that to make more informed decisions about where to expand your development resources. Data is an asset of your company, a precious resource that aids you to do your work. But what you can say about our code? What are the economics of coding? Code is valuable, of course. After all, it's from code that we made all that systems that capture and extract value from that data. But when you talk about coding, we often talk about money and time. Code, we often talk about the term in terms of costs. How much is this feature will cost to me, or how much I need to keep maintaining under a given budget? What I need to do? Engineering. That's because engineering is time. Engineering time is a costly resource. It's very expensive. That's the thing with Agile, Lean, Kanban. That's why we build MVPs and run design sprints. They are all processes and techniques to measure and reduce cost and time to market. They are ways that we found to be as assertive as possible and reduce waste. Even ourselves, developers, and here I'm assuming that most of you listening are developers themselves, even us, we learn about solid, dry, and DDD. All those practices, new languages, sharp tools, are ways to, we do that because we want to keep our code bases manageable, maintainable. They are meant to tackle big products full of features and somewhat make them small, conceptually, so they can fit on our heads. Otherwise, we cannot reason about them. And when we cannot make them small enough, we split them apart and handle to different people and call them microservices, right? That's the word of the moment. I'm the first one here to say microservices. The point here is code is a liability. It's a thing that you have to keep under control. Otherwise, you only slow us down until we are out of the race. Don't get me wrong, I really like to code. Code is really fun. But we have this common misconception on our industry about we are being paid to produce code. No, you are not. We are here to solve problems, period. Code, it just happens to be that thing that we found that's the best thing to accomplish that goal. But creating innovative business, of course, requires software to be written. But we have to write as few as we can. Less is more. Carrying less weight allows us to move faster and become maneuverable in this process. You know what happens when you spend too much time building a thing? You become attached to it. And that's the issue. Your code should be a disposable inventory. Software is called soft because it's made to be changed. New customers, new competitors, partnerships, opportunities, and even dealing with acquisitions or our environment is in a constant flow. Change is the only certainty we have. So change is the thing that we need to optimize. Now you are ready to talk about code as data. As a notice, I will talk about some pretty old ideas, some of them more than half a century old ideas. I will talk about macros, of course. Anyone here knows about macros? Use language with macros? Cool, a few hands. It's a concept carried from since from those old Lisp days. And we are pretty lucky that they are more commonplace nowadays. Macro is a compiler extension to make code as a template. But we don't use string interpolation for that. You use data representation of our code. The compiler will feed to our macros that representation. So our macros can rewrite our code and give a new code snippet. Let's look at an example. This is just a hello world, of course. Have this println function that will print that string. Now, take a look. See, the parenthesis goes outside, so we have a Lisp here. We have jokes about Lisp, but this parenthesis thing is not only cosmetic. What you have here is a data representation of our code. In Lisps, our code is just a list, so parentheses define lists. Our code is a list where the first element is our function to be called and everything else is an argument. By the way, Lisp stands for Lisp processor, so this makes more sense. Imagine that we want to write this thing. It's just an AND operator and two print expressions. Imagine that we want to write the AND thing. So what are the rules of ANDs? We'll have everything's true, it will return true. If something is false, it returns false. That's a gotcha. If it have like a short circuit capability, if any expression is false, it will stop evaluating everything else further. Let's make a first try. This is closure, so don't bother with the details. This snippet here is just defining a new function. If this function receives no arguments at all, it will return true. The ampersand expressions means that it will receive any number of arguments. It will run through those arguments, get each one, and if they are true, they keep evaluating. And if something is false, it stops evaluating and returns false. At some time, it will exhaust all those expressions, and then we will fall into the empty case, and returns true. So if everything keeps returning true, eventually it will return true, right? So that looks like it makes the thing we want. So back to our snippet, the println. There's this thing, the print function. It returns nil. It prints to standard out and returns nil. In closure, nil is false also. It's like Ruby, where you have false and nil as false values. So what we expect that happens? We expect that we will print the first thing and the second one will not print. But that's not what happens. It prints both functions. Why? Lisp have an evaluation rule where it evaluate the innermost expressions first and pass all the evaluated values to the outmost one. So it will evaluate the first println, and that's why you have that output. It will evaluate the second one, get both nils, and only then pass to our end function. So our end function will returns false, but you don't have the short-circuiting capabilities that we want in the first place. So how we can make that, we have an escape hatch for that? Of course, that's where a macro came. As you see, the structure of this code is pretty close to the functional one, right? Even the first case is exactly the same. But the second one, don't bother with the syntax thing. But what it's doing is interpolating your data inside the code template. So what it really is doing is rebuilding this end expression as a series of ifs. So it is not executing that if else. It's really rewriting your code. So it passes everything as is to the macro, and things works. Of course it works because it's a slide, but I promise you that if you take that snippet and runs it on your computer, you'll be exactly the same. So this macro runs at a different, like I said, it runs in a different time. It runs on a compilation step. In fact, in a phase called macro expansion. This is the time where your compiler gives the code, your macro, and gives the opportunity to rewrite that code. After we're doing macro expansion, we get this. Like I said, the series of ifs. So this is what your production code will see. It don't even see the macro. Macros are tools to build languages. If it sounds powerful to you, that's because it really is. If anyone here is dealing with JavaScript and have to deal with transpilers, it's like Babel, so can have future JavaScript features. Imagine have that power of getting new language syntax level things and rebuilding to old stuff. Imagine have that power at your language as a built-in feature of your language. That's what a macro does. Okay, so a practical example. I really like core.async as I really think is a great example of that. Core.async is a Clojure library inspired in the Golang language. Golang, have this neat concurrency model of Go blocks and channels. In Golang, they call processes, I think. Anyway, I have this Go thing and channels. And it's really a good primitive to build concurrent systems. Unfortunately, Clojure don't have that until Clojure core.async was invented. Now you just need to import this new library. It's just as any library you import and use it. It looks like this. This is how core.async looks. It has this Go thing. Here, this example, imagine you have an input channel. You take a value from that input channel, process it with a function, and put the result on an output channel. The Go thing here is a macro that will walks all your syntax looking for those arrow-ish things and rewrite it into and make it a state machine. That state machine, you make use of whatever primitives your environment have. Clojure runs on the JVM and also on the JavaScript. So you can run Clojure on your browser. And core.async, you do the right thing for that environment to make the semantics, to keep them semantics the same. It's very complicated thing to do by hand, but using this kind of syntax is really straightforward. That's what that snippet before looks after macro expansion. And I'm really happy to not have to write that by hand. Another quick example that I like a lot that we use macros is Elixir's Acto library. I'm not really an Elixir alchemist, but I think that they lack some parentheses to my taste. But Acto is really a neat library. It's in the same niche of Ruby's active record, is a data mapping layer. And it uses macros. So this from thing is a macro. It uses that so you have this SQL-ish syntax, then can really integrate with your Elixir environment. So imagine you have this threshold thing is a free variable you get from the parameter as an argument for a function. And it can really take that and write the correct and secure SQL string. So it's really a great library. Macros have this sense of being in a meta level. We start to talk about the code itself and treat that code as data. In fact, language that have macro capabilities, they are built themselves. They use a lot of this to build the language themselves. So if you get Clojure, Elixir, I believe Rust also have that. They are designed to be just a few primitives, and everything more higher level abstraction in the language is built with macros. So they use that to create new syntax. I would say that macros are a way to achieve great productivity, not only in having to write less thing and they will spit all the boilerplate for you, but also to learn stuff. You don't need to be like a really expert in concurrence to write a good concurrent code. You just need to know the few primitives that core.async exposed to you in the example. So you can use that the macros as or creating these new DSLs, so you can not only be productive producing your code, but also in the learning, the hump up phase. Of course, it's not all unicorns here. The problem with macros is it's really they are meta level, so they're more difficult to think about because now you need to think about rewriting your code. So abusing macros can create a lot of complexity, and remember, complexity is the thing that we want to avoid. So we end up just following the Uncle Ben's rule. Great powers can create responsibility. Macros are useful, but you should really try to use with a lot of care. We have that test pyramid where you have end-to-end tests at the top and unit tests at the bottom. So it's kind of same thing with macros. You have macros, a few macros, lots of functions, much more data. That's a good balance for your system design. So don't use macros for things that you can resolve with functions. That's the common guideline and could bring you a good mileage if you follow it. So we talk a lot about code being used as data. That's the macro thing. But what happens when you change things around? What are the implications of using data to execute it like a code? The implication with that pyramid is that the same way that we can get everything we do with functions and move a layer above doing with macros, how we can push that thing to a layer below and get that database thing going on. I'm not talking about eval, for God's sake. Please don't evaluate random strings from the internet. That's dangerous, right? So no eval. I want to make a little digression about abstraction. Use that in your favor. Languages have many tools for abstraction, from functions to interfaces to fancy type classes. Pick your poison. Abstractions are a useful thing to make our code reasonable. And I'm not talking about anything fancy at all. Just split the work you have to do into small pieces and give good names. It's already an abstraction. And you can call a day doing only that. The outcome of doing that is that we get all those small procedures, and they are all reusable. You can just call them instead of repeating yourself every time you need the same functionality. Of course, I'm being boring. But I want to invite you to look at those things as business primitives. So in the same way our language have ifs and elses and for loops and whatever it have, we are in fact creating new business primitives. They are no different. Like think our e-commerce example again. You create some compute shipping thing and place yard and stuff and notify customer. They are primitives for your domain. You can combine them a la carte to produce your workflow, the business workflow you need. A useful thing in terms of polymorphism too. Imagine that compute shipping is an interface, just a facade for other stuff. Maybe it's an interface, maybe it depends on the language, of course. With that, you can have, with same semantics of compute shipping, you can have different implementations. You could have a compute shipping that use cached information and have characteristics of cache information, and have other implementation that relies on external services to do that, to do the work. Polymorphism is a way you have in your languages to create options. So sometimes you need as interchangeable behaviors. Other times we can use polymorphism to protect us from the future change. When I talk polymorphism, often we think in terms of the code again. Here I have the closure. This is a protocol, so it's similar Java interface. It has a name. You have a signature. I want to point out that you have this signature, the compute, and the order are the parameters, of course, and the provider, this first argument here. The provider is the identity of the thing that will implement this interface. So you can have different providers with compute semantics, and they will have different implementations. So when you think about this, the HTTP call, it's the same thing, in fact. You also have a signature, HTTP verb with a given data format, a contract for the shape of your data. This is the same thing as the interface of the example before. And the endpoint itself is the identity. If you respect that same contract but points to different endpoints, you could get different implementations. So again, you can think that on the this change theme in your favor. You could have shipping local to local addresses and have international shipping. They could have very different rules and have different endpoints for that. Or maybe you are trying to take a partnership opportunity, and your different partners have different implementations of this endpoint. They just need to respect the contract. So what we are really creating here is the polymorphism at the level of your system. All those things, they really are the primitives. Again, they talk about the how things should work. They are well defined and somewhat stable. If you want to change that thing, they are stable enough that is a cute place to make with code, because really when things like the service contract change, your service implementation change, is more because a bug or something like that. It's not a behavioral thing. But eventually, you hit a glue layer, some layer in your system that have to keep all those pieces and get them to work together. Do you know MVC is a common design pattern for building web applications? Imagine this is a controller handler. So it works like that glue layer we talked before. It will orchestrate our different places and put it in order. It specifies what should be done. The thing is, describing what should be done is a descriptive thing in nature. So it often have few logic, if no logic at all. Looking again, this code here is most boilerplate. And you can do better when you are dealing with boilerplate. Maybe resolving that with macros. Or we can think our glue layer as data. So you get that capability of treating data as code. So we get to the thing here is designing some information model about those primitives. So you have implementations of each of those concepts, and then let's get to the next slide. You have implementations of each of these operations, and you start to create data descriptions about that too. So in the same way you have schemas for your entities, you could have schemas and semantics about the operations themselves. When you make things like that, your operations become just messages. And the thing with messages is that they don't really bother where they come from. They could be came from an HTTP request. It could came from a queue, streaming queue, or they can be just embedded into your code. The implementation of your handlers themselves is really generic. You be run this scheme thing. It really is akin to the interpreter. So like you have a runtime for your language, you create a runtime for your system. So, just to mention, anyone have heard about AWS Step Functions? Yeah, it's pretty new thing. Just you, I believe. It's pretty new thing. AWS Step Functions is a new service they created that is kind of workflow as a service. So you could think that that's this thing as our glue layer we talked before. It's not specifics about AWS here, but I like to use it, so it's something that you can toy in your home. AWS Step Functions have this this schema for how to define a state machine. So just a hello world. And this schema is just a JSON thing that you send to them, and you create your state machine, and the actions themselves you just dispatch to some other thing to have the work. So you could dispatch to HTTP endpoints or even AWS Lambdas if you are into this thing. You are trending. Cool. That JSON thing will build this state machine, so it's just a hello thing. It's pretty cool. You have a visual representation of that. Sorry for the crap screenshot. I'm just lazy and grabbed the first thing I found on the documentation side. And here another screenshot. The cool thing here is this is a kind of web console for the AWS Step Functions. And the cool thing here is given that this state machine, this orchestration thing is just data can be projected into different formats. So first we have this JSON document, right? And now you have a visual representation of that. And you can really use that console, the visual console, to change the state machine definition. So you even don't need to write the JSON by hand. You can just use that. And imagine the collaboration opportunities. So, example, you could pair with a business analyst to create new workflows for your whatever you are doing. So, as I said, you can project data and and make it more meaningful to other folks, even some non-tech people. It's like the same thing we did with core.async. As I said, we don't need to be an expert in concurrence to build concurrent stuff. We just need to know how the core.async primitives works. So in the same sense, imagine a business people. It don't need to know how to write a Lambda function. It just needs to know how that Lambda function, what are the semantics, what that Lambda function can do. They are smart. They can understand that. And you can use this and leverage this. So other people could start to write these workflows. Again, data can be put on wire. So we can create these definitions in a service and send them on the network to other services. They can be stored, can be query. So you can imagine now these descriptions of your system flowing on it. If you have services producing descriptions for other services about how they should work, probably things could get messy, but data can be inspected, can be validated. You can instrument your data. We do that all the time with the data we get from our customers, like sign-up form. You validate your sign-up form. You can validate that data description. You can really get code crazy and create this system-level macros. So imagine you have a higher-level description, and you can use that, a service or some piece of code can get that and expand to other small finer-grained descriptions. So you can really layer. You can create systems of systems of systems. Turtles. Well, so what? We can take from here. Pursuing the properties of this architectural style can create a healthy amount of design pressure on your system. It's the same thing we have with TDD. TDD practitioners, they tell a lot about how a code that is difficult to test have a smell that your design is not so good. Probably, maybe it's just have too much coupling. Maybe it do too much stuff. So, in the same sense, trying to pursue this style of architecture, you need to have this well-defined contracts, well-defined boundaries. You have to split. You need to have a good split on the whys, on the hows, and the whats of your system. So following that, trying to make something work like that, you create this pressure, and you have the same feeling as design tool. And all this data thing, it's really useful in creating this runtime polymorphism for a lack of better term. But I like to stress that the bulk of the exercise is just a matter of applying careful design. It's just following the guidelines of high cohesion and low coupling. The data part is just the ace on the cake. And at the worst case, you can end up with a data-driven, serverless, microservice architecture which could earn a few internet points, because there's a lot of buzzwords. Jokes aside, just a final thing, I want to ask you to not forget. Things will change. So build your software for change from the ground up. So thank you.